so I don't forget.
No, there's no way I'm online.
What?
What if I say I don't want to be recorded?
Then don't talk. Shh. It's not. It doesn't have your likeness.
Okay, I won't talk for the rest of class.
And however, weirdly, the school has already made you sign a form saying that your likeness can be used in any way that the school sees fit.
Yeah.
That's how we can take film and pictures of you playing sport or anything and just use
Actually?
it.
Yeah, you already signed
You already signed that away.
yourself away.
Oh well.
More accurately, your parents.
Where did I sign myself away for?
Yeah.
Unlucky.
Permanent indentured servitude.
What's that?
Welcome to the jungle.
Well,
I'm about to give you all weapons.
Yeah, we got weapons. Finally.
Already half, yeah.
Does mine go boom?
Boom, boom, out goes the lights.
Or even nap time.
No, we are going to be doing a lot of chemistry very quickly.
Monday, it's the last period. I think y'all deserve a nap time.
You mean it's the first period, because this is the only one that matters.
Very
Yeah,
important
baby.
Question, Move.
Pardon?
Very important question, Move.
Yeah?
Could you make me a flashbang?
A flashbang?
Yeah, for paint.
Oh God, I made ammonium triiodide. So you take ammonia and ammonia, and you replace all the hydrogens with iodine. It's a contact explosive. It's really cool. My professor at university would have it. He'd have it in these little packets, and you throw it out on the ground, and it would go bang. So you can just throw it around like, you're the Wonder Wizard. Bang, 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 bang.
You can also take a handful of rocks
Pocket
and dirt
grenade.
and just throw
Yeah.
it into the
Oh, it's a loud bang. You definitely know those explosives.
It's
So I
fucking
made it,
definite.
followed the instructions. And it doesn't explode when wet, so you have to smear it on a piece of paper, dry it, then very carefully take it off. As it's drying, it's exploding. Like just the slight vibration in the room from like a passing wind on the piece of filter paper, bang, and then it would blow up and fell over the floor. And for about 2 weeks, you walk in the science department and you stumble forward and go bang, 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 every time your foot hit the floor.
Oh, that's cool.
I don't know how that professor made it stable long enough to get it into the paper, but it was insane.
Look, Ellis had a paintball too. And Eli
No.
was down there.
I'm not in there. No. I set up a demo that's probably going to be used next day.
Friendly fire.
I'm in here tomorrow morning. If I can just leave this. I'm gonna do that.
Yeah, I'm not doing nothing. I ain't doing nothing. Oh, you on that side?
Sounds right.
Dun, 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 dun. Okay, get your notes out. We are starting in 1 minute 30 seconds. Go, 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 guys, machine, phones away, laptops out and ready. iPad, Josh. Or notes, whichever you like. Put laptops away though. Laptops away. No doing other courses while my course is the most important course.
Flash book anyway, so nobody's doing.
That's what everyone says. Every teacher says my course is the most important course.
When you're in this classroom, it is. When you go to English, your English teacher's allowed to say that because you're in that course. Just like this is my favorite class. Because you're the ones who's here. Those other classes could have chose to come here and skip the other class, but they didn't. You came here, so you're my favorite class.
So if I come to your A block or B block.
That will be my favorite class. My class is the one that is here.
Okay.
Okay. Nick, Tim, laptops away. Glenn, laptop away. Away. Take the Republic of Gaming.
We're gonna do a lesson today for 20 people.
Yeah, we're going to be doing a lesson every day. We're going to be going quickly. Boom, boom. Out go the lights.
Do we have any more big tests before
Oh, yeah.
final test?
Yeah, immediately after midterm, you have all of acids and bases.
A test?
And I'm hoping to really take that down.
Okay, there we go. We left off last day with the discussion of a strong acid and a strong base and what the titration curves look like. With a strong acid and strong base, titrating into the acid, and you could do this either way. You could titrate a strong acid and a strong base like this. You get a curve like that, and the curve just looks mirrored. It's the same, it doesn't matter which way you do it. Since they're both strong, it doesn't matter. When we use weak things, we'll find that it matters. I have because hand drawing titration curves isn't always the best, I have included some drawings so that you can take a look at them. This is a 0.1 molar versus a 0.1 molar HCl, I believe, strong acid, strong base. So you have a titration curve.
Do you have another copy?
Yeah, there's lots. You should be able to come up and grab one. And there's one when we start with the base in the bottom, and we titrate in HCl. So we're going to start with a weak acid, strong base.
They look cute.
No, that's the one we're doing next. I'll take one. No, you can take one, but no, we had tons. Indicators. Like we had so many.
Are we on P or are we on chart?
Well, we're at P, there we go. Tons. I printed too many because I forgot about how many people do it the other way around. Lavina, focus, notes out. We've already started. Okay. Sonia. Next. Excellent. We have next one, weak acid, strong base. If we again have our Erlenmeyer flask, you've done some titrations. And when you did the titration, where was the weak acid? So that's the burette. Erlenmeyer. Where was the weak acid?
In the flash.
In the flask. So, weak, always, otherwise, in flask. I have misspelled always, but I'm not going to correct it. Maybe I'm having a stroke. We'll use that as evidence later. So we have our little solution here. It works better to have the weak acid or base in the flask because the NaOH, and so classic strong base will use NaOH.
There's no packages?
Pardon? We're still on P. Same one as last day. So this is going to be NaOH, and let's go with some sort of weak acid. Favorite weak acid, Andrew.
Favorite weak acid?
Weak acid.
NaOH.
That's a strong base. That is you did the opposite of every term.
Is it?
Yeah, which is almost like that's almost perfect because you just had the opposite.
True.
Yeah.
Let me just get out my.
Data table. Sounds good.
PO4?
Pardon?
PO4?
Vin de bois?
PO4?
Pio board? I can't understand. What?
PO4.
PO4! -3. Just that? That's also, there's no hydrogen there. It can't be a weak acid.
Oh, we gas.
Weak acid.
Don't do it. Right.
HS.
So, weak, you said weak,
Weak?
weak acid.
Weak acid. Any weak acid. It could be strong weak acid, it could be weak acid, any weak acid.
HPO4.
HPO4. HPO4, what's the charge?
2 minus.
HPO4 -2. Excellent. So there's our weak acid. If we're going to do that, and we titrate it, where does this pH line start? Up or down? Weak acid in here. If we're measuring this with a pH meter, do we start at a low pH or a high pH?
Low.
No, why?
Because it's acidic.
It's acidic. So we're starting with an acid. So it will start somewhere down here. And we get this little upswing, sort of a curve like this, a titration curve, and then up and over. This area Samuel, not distracting Andrew, getting your stuff out, getting going.
Is there a little curve at the start?
So yeah, there's this little curve at the start. We get an initial upswing. And what, compared to the previous one, what can we say about that range? We had a range in here. And then what can we say about the range in there? So if we did the range here for our upswing, not our upswing, but our actual titration, we would go here to there. Compare that to this one. Question is, what is the difference between the range here and the range here in terms of the amount that you have to add for the titration?
Double.
Double, it's larger certainly. So there is a wider range.
How do you tell that?
It is not as steep. So that curve is a shallower curve. The initial pH here should be higher at the same concentration because it's a weak acid, so not all of it is dissociated. And you get an initial upswing in pH at the start of the titration.
Don't scroll yet, please.
Won't scroll yet, but you notice I started very low down here because you're starting low because you have a very strong acid, but here starts much higher.
What's that red again?
Starts higher.
What does that say in red?
Initial upswing. It's this area right here. You get an area that looks like this.
Okay.
I should do it in red, different color than that purple I was just using. So you get this curve. Sometimes students think that that's the reason I mentioned it. Sometimes students think that that is the pH curve, like this. They think, oh, it's happening right away. No, it just, as the equilibrium reacts, it just does that. Now, if we were to then take this one, right? We have sodium, hydrogen phosphate, plus NaOH. Write the net ionic equation. So what does net mean? Sonia? What does net mean?
Add
Complete. Usually do the complete before you do the net.
Cancel out
everything
the
added together.
spectators, like,
Yeah.
cancel.
Net means no spectators. So take out all the spectator ions. Anything that be aqueous on both sides, that can be canceled out.
Wait, no, I thought it was. Or no, that's the.
Complete is when you have every ion in there on
Yeah.
both sides. I usually do that in order to find the net. For this, just you can just go straight to the net.
Okay.
Let's do another one. My favorite weak acid is always HF, because I think it's one of the few halogens that is actually a weak acid. Do the same thing. Ooh, and let's do one that has a couple things. So let's also do different color. H3PO4 plus NaOH. And give me the net. I will quickly do attendance as you write those down, and then I'll call in some people to give me the products. Schedule. Where is everybody? Because there's one thing they can't be doing is studying for AP chemistry. Etienne is here. Labina, Theo, Josh, Samuel. Thank you for coming to class. Ella is not here, but we got Sonia, Andrew, Nathan, Katie's not here, Nicholas is here, Kaz is not here. We've got Gleb, Max, Ashley. Neha is not here. I'm going to start at the back. I've already called on. Where'd Samuel go?
I'm right here.
I was going to finish off with Andrew, but then I'll just put you further down the line. So that means it'll be 1, 2, 3. Perfect. Gleb, what's the first one? Or actually, you're the first one. Do it. Pick. Pick which one you want to
Net
do.
ionic, or like,
You did net ionic, yeah.
it'd just be for the first one, HPO4 plus OH minus.
HPO4 plus OH minus.
Is PO4 3 minus plus H2O.
PO4 3 minus plus H2O. You're missing just one charge? Or an area?
HPO4 is supposed to be -2.
-2. Excellent. Why didn't you separate, why isn't this H plus and we just cancel out the PO4?
Sorry,
You're right, just so you know.
it's aqueous.
It's aqueous. When we normally cancel things out, it's because when they hit water, they dissociate 100%. There is no such thing as NaCl aqueous. When we say that, what we mean is that there's Na plus aqueous plus Cl minus aqueous. It is 100% dissociated. And if it's not, like it's AgCl, any amount of that's just solid. There's a tiny bit that's aqueous. You don't get whole things. Whereas with weak acids, that whole thing's aqueous. It's dissolved in solution, and it doesn't go away. So one of the first differences between net ionic and solubility is that, where should I write this down? Down below. Weak acids and bases are not removed from net ionic equations. So, good instincts.
Oh, isn't H2O liquid? Pure liquid?
Oh, yes it is, thank you. Okay, perfect. The next one, Josh.
Can I do it first? Some go.
Okay, then you'll do this one?
Sure.
Okay,
I'll do, okay, H up plus OH minus. And then it's arrow F minus plus H2O.
yeah. So the only thing that's on there, you got rid of the sodium.
Yeah. Whenever you have OH base, then they say OH acid base, it's always taken on that conjugate.
Whenever you're ready, Josh.
Almost. Bro, just try it. Just look at what I did in the previous one. It's still the same.
What stayed the same on both sides in this one? Right, so what would stay?
H3PO4
Very good.
to
OH minus, excellent.
How would you write the,
Is it PO4 H2O?
PO4,
it's H2P?
Oh, H2P.
is it H2PO4?
Because if you have H2 on
Oh.
the right, then you have to remove one.
So this is one of the reasons I like this one.
Yeah.
How many of you have H2PO4?
Yeah.
How many of you have PO4 3 minus? Ah, it was roughly even. How many of you don't vote?
I forgot to vote.
Ah, excellent. If I say you don't vote and then you voted, you have just proven yourself to be a liar. It's PO4 3 minus is the correct one.
I had that.
For the record, excellent. Now why? This is a strong base. It will react with every single hydrogen. So strong, it's not like when we're just doing a reaction on hydrolysis where it reacts with water once and we show the equilibrium. This is not an equilibrium. It reacts with all of them. And then what do we have left to do on the equation?
Just balance.
Add this.
Just balance, yeah. So how many hydroxides do we need?
3.
3. Anything else we have to balance?
3 waters.
3 waters. Strong base. Reacts with all hydrogens available. And it forces the reaction all the way to the end. Good.
How do you write the overall equation for the H2PO4 plus NaOH?
How would I write it if it was NaOH?
Yeah. No, like not the net ionic, but the general.
The general?
Yeah.
Like just you'd put the sodium back in. H3PO4 plus
Oh, whatever.
3
yes, okay.
NaOH, right? And then this would be Na3PO4, and then you just keep going.
Was it say all weak acid bases are not?
Weak acids and bases, as in weak acids and weak bases, are not removed from net ionic equations.
Wait, but why is it 3H2O? Shouldn't it be 2H2O?
How many OHs are there? It will react 3 times. 1, 2, 3 with each of those H's. So there are 6 hydrogens and 3 oxygens. We need 6 hydrogens and 3 oxygens.
How does it become 3 odors?
Oh, you have to balance. It has to go to PO4. It's going to react with all 3 hydrogens.
I'm just confused on how it is. Because this is the solution.
Is anybody still writing the notes? Okay, next one. Weak base, strong acid. Let's take our Erlenmeyer flask. This is a terrible Erlenmeyer flask. And then we have our burette. If we have a weak acid and we have a strong acid, let's use HCl as our strong acid, because that makes everything nice and easy. What weak base shall we use? F minus will work. So let's use NaF, which is where? What are you titrating into and what is in your burette?
The acid. I'd said the weak base.
Which one is the weak base?
The NaF.
Titrating the weak base.
Which is in the burette?
Oh, it's in the bottom. It's in the bottom.
Which one's in the bottom?
The NaF.
NaF, which puts our HCl here. And that was on the last slide, weak. And then the strong always, it always has to be weak and strong. You need one that's going to make it go in a one-way direction, so you always want a one-way arrow. Where will if we start down here with a weak base, where will our pH start? High or low? High. And not as high as if this was a strong acid, strong base titration like the first one. It's not going to be super high, but it is going to be higher than it. It's not going to start down here. It's going to start up there.
So if it was a stronger base, it'd be higher.
Yes, and I'll show you a series of titration curves that will show it based on the Ka as well. So before we had an initial upswing, with this you get an initial downswing. Sort of goes along like this. Then you get an area like that before it goes out like that. Once again, you get a wider range, same as before. Ooh, I've got to go back. I didn't realize this one. This will be a pH of 7. So equivalence point. Less than 7. Why is it I'm going to have an equivalence point that's more acidic?
What does it say?
I'll come back to the equivalence point. I'll come back to that.
Because you have a strong acid.
That is often how people remember it, but curiously no. Because it seems to make sense. I have a strong acid, equivalence point is acidic, but it actually has nothing to do with this strong acid. I'm going to stop there because you can go back to the other one. This is a point I didn't forgot to put in. Can I go back? Anybody goes? Keep right? Okay, good, done. Back one. Here is a pH of 7. For this one, we have an equivalence point. Equivalence point above 7. So when we have a weak acid, strong base, it's above 7. When we have a weak base, strong acid, it's below 7. And it's not due to the strong acid here, and by complementarity, I will give the hint it's not due to the strong base here. But your equations down here probably give you a hint if you look at them. Why would we have an equivalence point when this reaction is completely done? So you've reacted everything, there's nothing extra. Why would this?
Because you have a weak base.
You have a weak base. You have an equivalence point above 7 because you create a weak base. You'll put there's a lot of arrows, but created weak base. And since you've created a weak base, when everything's stoichiometric and you've neutralized the reactants, your products are now reacting, and we've created a weak base from our weak acid. I'm going to click, provided nobody yells. Now we can go back to this one. Equivalence point less than 7, because what did we create here?
A weak acid.
A weak acid. We have an initial downswing, and here we have initial pH lower, then a strong base, because we're starting with a weak base, so it's not going to be as basic. Volume of acid. I think we made most of the points of the other one. I don't think I'm forgetting anything on this one. So let's do a couple of similar ones here.
Hold on.
No more caffeine, sadness. So let's do some equations. We've got NaF plus HCl. Give the net ionic. So I'd like that one. Let's do a similar one to the other one. We always use Na for everything. I should change things up. Let's go with K2HPO4 plus HBr.
Initial pH is lower than strong base.
And let's do NH3
Is a strong base would be
plus HCl. I want the net ionic equations for those.
because they are more about the table. And they
Because for that one under drops, just the NA and stuff like that.
Yeah.
This one, because it's weakly strong acid, you drop.
So strong acid is going to dissociate 100%. So on the acid side, what do you drop?
K is
ACL? No.
Well, you can't drop the whole HCl,
No.
but it's going to separate 100%.
Drop the CL.
Drop the CL, or the second one,
for the first
Yeah.
you'll go NaCl.
No, EBR.
the BR. Yeah, whatever's with the strong acid, you can drop.
Okay.
And then on the left-hand side, what can you drop from those?
H.
Can't drop the,
Or the N. Okay.
because that it dissolves the what?
The N.
The N, the Na and the K. Yeah, because those are just there so it can accept a proton. So it needs a positive charge. So when we go and find them, we'll have their positive charge.
And how do you memorize this?
Well, from solubility, we know that sodium and potassium are soluble with everything. So,
Okay,
it's the same. So it's that part's a solubility thing. And then weak acids and weak bases we don't dissociate. But weak bases can have no hydrogens. But some of them can, like, so we keep them. We keep them in this case. Why don't I jump to Nick? You want to pick one?
That could also be wrong.
Sure.
NH4 plus
Hold on, NH.
NH4 plus Cl.
NH. That's nowhere on this side.
Because they are interferons. So when you
Oh, are you just giving me the product?
Yeah.
Oh, I want you to give me the reactants in a net ionic equation. So just start off with the reactants.
So that'd be
That would be what? Does this dissociate 100% in any particular way?
not sure.
Does it seem familiar at all? And from solubility, you know, alkali ions do plus ones. There's no alkali ions there. Is it strong acid or strong base? Pardon?
Strong base. So
It's not a strong base. It's a weak base. Can you find it on the base side? Yeah. So there it is, base side, weak base, and we don't separate weak things. It's just ammonia by itself. That's all it is. There's no charge. There's nothing. It's just NH3.
Oh yeah, it'd be H.
oh,
What's this?
yes.
But is that strong or weak? Strong acid. So which one of these then disappears? Which one is the spectator in HCl? Pardon? The Cl, yeah. Because it separates, the Cl is useless. It's the H plus that sticks around and does the reacting. So this is our spectator. So it's just NH3 plus H plus.
Then the BR. Plus BR.
Yeah, it's Br minus.
And then what would the product be?
Would it not be NH4 plus Cl?
Ah, well,
Or NH4?
it'd be NH4 plus.
Plus Cl minus.
It's, well, if you kept it here, what's the spectator?
Cl minus.
Cl minus.
Oh, that is a.
Yeah, so Cl minus is definitely the spectator. Because if you take HCl,
But isn't Cl minus a?
goes to H plus, whoops,
Oh,
H plus Cl minus, right? 100%. So this is actually H plus Cl minus. There is no HCl aqueous. It's just separate. And if you have NH4Cl, well, NH4, if you look up at solubility, it's soluble with everything. This is actually NH4 plus Cl minus. Spectator. So you can get rid of the Cl. Strong acids, you can often get rid of those. So what's left is just NH3 plus H plus goes to NH4 plus. It is a proton acceptor. It accepted the proton and became its thing.
So say like acid, then you wouldn't be able to.
If it was a weak acid, yeah, then you wouldn't be able to. So if this was, so the reason that works is because this is a weak base and a weak acid. Sorry, strong acid. But if we had NH3 plus, say, HF, weak base, weak acid, this does not separate 100%. It just stays as it is. You would get some sort of equilibrium, and you'd get NH4F.
Would it be NH4 plus F minus or?
It might, oh, because that does dissociate. Plus, F minus, aqueous, 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 aqueous. And nothing cancels out. Yeah. But we don't ever titrate a weak and a weak. You always need a strong. So you won't encounter that. Now,
One beats up the other.
yeah, one beats up the other. Let's move across. Sonia, finish off one of these.
The first one.
Go.
HF plus CL.
Hold it. First one, what do you say?
HF.
Are you doing the product? I want to start at the reactants.
Okay, so NaCl plus HF. And then that goes to HF plus Cl.
That's not the reactants.
Why?
Well, there is no NaCl here.
What
This is not the reactants.
what's the...
So let's see.
Oh, wait,
What separates 100%?
Wait.
So let's go through the complete. Does this dissociate 100%?
Yes.
Yeah, it does. So if we're going to do the complete first, it'd be Na plus F minus, both aqueous, plus, does this dissociate 100%?
No, yeah.
Yeah, it's a strong acid. So H plus Cl minus. So we could start off like that, and it's going to be a one-way arrow. What's our product?
Wait, what's, like, how do you know what to, like, how do you know what to, like, draw? Like, just go to the product.
Well, there's only one in there that's, which one's the, this is the strong acid, right?
Yeah.
So what's that?
Weak base.
Weak base. So which part of this is the weak base?
The
F. That's just a spectator on it. So we have the F. What's it going to do if it's a base? It's a proton
this just
Acceptor.
acceptor.
oh,
So it's going to accept that proton. It doesn't dissociate 100%. Right? And then what are you left with? NaCl. But those dissociate 100%. So if you were to keep doing the complete, those are both aqueous. So if you cancel, then you just get F minus plus H plus goes to HF. The base net ionic feel weird because they're not making water in any way, but they're just proton acceptors. They don't have to make water. The new definitions of acids and bases means that it's not a strong acid with a strong base with hydroxide. It's just a proton acceptor. So you just see it accepting a proton. And if we did this from first principles and you went all the way back to what does the formula equation look like, you would get NaF. Pick a different color up here. NaF plus HCl goes to NaCl plus HF. Aqueous, 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 aqueous. That's fine, right?
Yeah.
Like this would be fine. And then when you go to the next step, weak things do not get separated. So this would stay the same. That gets cut in half because it separates 100%. That gets cut in half because it separates 100%. And that gets cut in half because it separates 100%. So the weak things are the things that stay together. So that's why it's only Na. Everything else separates, only HF remains. And that's why you can cancel most of it. So moving to the next one, Nathan.
I didn't do it right. HPO4
Right? What's the charge?
-2.
Excellent. Plus?
HBr, yeah. Arrow. H2PO4 plus Br minus.
Charge on this one? H2PO4
1 minus
minus 1 plus Br minus. Now we've encountered a similar problem. This is a strong acid. So does it separate 100%?
Yes.
Yes. So this is actually H plus Br minus. So what cancels out?
You just get rid of it.
You just get, well, which part do you get rid of? What's duplicated on both sides?
The Br.
The Br. So
Oh.
what you get rid of
Oh, okay, yeah.
is the Br minus.
So it's HPO4 -2 plus H.
Yeah, plus
Yeah,
H
okay, yeah.
plus.
Yeah.
And the charge is bound. Overall, this is -1. Overall, that's -1. And we just see them joining up. So the net ionic for bases just look like them joining up because they're proton acceptors. And so strong acids are basically just the proton. The other part is a spectator. It doesn't do anything.
Hold on one sec.
One, two, three, four, five, six, 7, 8, 9, 10, 11, 12. Oh, you're already naturally in pairs. Good, Josh?
I'm just doing the top part, just the NA.
Oh, okay. Sure.
Oh wait, hold on, let me see one here.
Now we just have some examples. So you see real titration curves, not just the weird, ugly things that I draw. I'm going to view this so I can see the whole screen. So this is a weak acid. And by comparison, we have down here what would a strong acid be, ending up with a base. So if you have a weak acid, you want a indicator that's kind of around neutral to basic, because it's going to make its weak base. So you have a higher, God. Higher equivalence point. So phenolphthalein still works. Phenolphthalein has an equivalence point between 8 and 10. It works for strong acids and strong bases because that curve starts down here, goes so high and comes over. But methyl red, which changes down here, would no longer work. Methyl red would work for strong acid and strong base because you get that whole curve. But now it's going to change color through here. It's not going to give you that nice change of color with a narrow amount of volume of NaOH added. So there's our strong base.
What does equivalence point be?
Equivalence point.
No, point B.
Oh, point B. This is for the strong acid plus
Why
strong
is it
base.
on 7? Oh,
It's right. It's right on 7.
Wait, what does the word say before the comma?
Dude, what's WB?
Weak base made. So we're making as we're doing this, we're titrating a weak acid. As it's going over, it's making a weak base. So our equivalence point is going to be basic. So some of the questions you can get is pick an appropriate indicator for this titration for a weak base, for a weak acid, pick indicator pH is equal to 7 or above, because it's going to titrate somewhere up there. And depending on how weak it is, it might actually get above 7. You want it up in this range, depending on what it is.
An equivalence point 8 is a strong acid with a weak base. Oh, sorry, strong base with a weak acid.
Strong. This is a strong base with a weak acid for equivalence point A. Sonia, question? Good. Next page is just to give you a variety of weak acids with different Kas. So relatively strong weak acid, 10 to the minus 2 Ka, 10 to the minus 4, 6, 8. Notice, when you have the Ka of 10 to the minus 2, where is its equivalent point?
At the bottom. Or near the 7.
Oops. Equivalence point, little bit above 7. And notice when it's coming through, where this point is sort of in the middle of your there, you can look at it and often roughly guesstimate how long your titration is going to take and at what pH, because those 10 to the minus 10, the 10 halfway there is right there. So you can see the halfway point. Not the equivalence point, but the halfway point. It gives you some indication as you're going along, if that's useful to you. For all of these, you can barely get, if you have a very, very weak acid, sometimes you barely get any sort of curve at all. And that could be very difficult to do a titration on. You need at least some area that you can put an indicator in to get. So very weak acids are functionally not even acidic. Okay. Oh, and the other part, as they get weaker, what do you notice about how they start? There's a steeper curve. You get this upswing is noticeable right away. When you start adding a strong base to that, it overwhelms the equilibrium fairly quickly, and then it sort of settles down and starts to react, and you can start seeing that slowly go up until you get another swing. So this little upswing becomes more pronounced the weaker the acid is. Just to make sure you have the opposite, this is with a weak base and a strong acid, so we're adding our strong acid HCl. And this is with a weak base, we get our downswing, and in this case, phenolphthalein would be a terrible pH. For a weak base titration, an indicator 7 pH is equal to 7 and below. So perfect, right on the equivalence point here would be a pH of about 5. Methyl red would be perfect. Phenolphthalein won't work. It's doing it too much in the range in which you're still adding base. So you do have to pick the right indicator for these. What are we doing for our? What base is this? Oh, an H3. So this is an NH3 titration curve. It's also live streamed. You go to the live stream right down and take a screenshot.
That's okay.
'Cause I don't know how good your camera is from that distance, but.
Could you go back for a second?
Yeah.
Okay.
This is just to illustrate what you get if you have a polyprotic acid. So this could be something like H2S.
I'm so good at the game.
What's HA?
So polyprotic,
Oh, that's too crap right now.
Josh,
What's up?
question?
No, okay.
Polyprotic, many protons. You deal with the first proton. So this would be H2S going to HS minus. And then you go here and you would have S minus 2. So you take off the first proton, you get an equivalence point. You go through, titrate again, take off the last proton once you've taken it all off, and you get another range. So polyprotic acids will have 2 equivalence points. If you have something like H3PO4, you would get 3 equivalence points. As it would go up, over, and then it would keep going. And you'd titrate it 3 times. If you're doing titration with that, you would just pick an indicator that would indicate there, because you don't really care about that one. And then when it changes color, then you know you've reacted all of it. What's this one? Protonated form of alanine. Oh, okay. Someone's doing biochemistry. Excellent. You've sat down and did notes long enough. This is similar to the titration problems you've probably already done in your book. I've even set it up so you have it exactly the way it would have looked in Chemistry 11. We just want the concentration, and it is a normal concentration that you would have had last year. Example 1 has the table, example 2 does not. You have to make it up. Grab your current partner, grab a pen, go and do it on the board. Question 1 only.
I said for 2 notes. So H2, C2, O4, plus, and then OH. Are we doing like the net equation again, or just like normal regular equation?
I want the concentration of oxalic acid given all that data. So, and I've just summarized the data here. This is what I often do. When I read through a question is I summarize it that way and then pop it into the table. You're gonna have to write the equation across the top.
Let's go to the whiteboard.
Everybody has started the equation. I will write that in. And we've got NaOH. triangles. I don't care what method you use. That's the table method Mr. Snow and I used in criminal level talking last year. Pardon? Okay, she may not have done the table. Don't care what method you use. It's just a way of organizing your concentrations. When you make triangles, you're talking about the formulas.
Yeah.
This is just a way of representing your data. So N just means moles.
Yeah, I know that. And volume and concentration.
Yeah, this is just liters, and then this is moles per liter. So as you get the different pieces, you just put it in. That's all.
Is it 10 milliliters?
Balance in there. Watch your charges.
Actually, yeah. But it's more.
Watch your charges.
Yeah.
Well, you have made one of the things that is going to make your job very difficult is that your products, you have not accounted for the charges process.
Oh.
1 milliliter.
There you go. You will find that very, oh no, you got it. I didn't see it, my glasses were up. Oh, there you go. You will find moles of that difficult to balance. You need to check your products. You've done something with your charges. You want to check your products in general. You've done one thing good and one thing's different. Do acid-base equations make acid?
Pardon?
Do acid-base equations make acid? Well, if you're doing the net, you should do it on both sides. Because you got rid of something. No, then what did you get rid of? So if you're going to do that, you're going to do the net. You should get rid of it on both sides. Otherwise, it doesn't.
Oh, wait.
That's all. You can do the net. That's fine. There we go.
That gives us.
No.
Is this this?
Two. Yeah. One way versus the other. We did it.
Woohoo!
Wait, what? I think you put that in the wrong spot.
Did it? Oh, it's the NaOH that's that.
Yeah.
That's what we're looking for.
You
I don't know what you're talking about.
Do you want us to need a multiply these two?
What is the Excel constant? Determine the moles of unknown.
Oh, you have done something incorrect twice and canceled it out. So you have the right answer. But if you were to show your work like that, there'd be something a little off. Unless you made a statement that how you know.
Did you want me to show more?
No, there, you have made there is absolutely not 7.239 moles. That's a lot, first of all. I'm not sure that might have resolved the solution. There's a way to fix it while keeping the number. There's also another way of fixing it, and then you get the right number of moles. But you get the wrong answer because of the way the stoichiometry works. You multiply by your mistake and then you divide by your mistake and it cancels out. And so you don't have the right answer. If you could figure out which one that is, Glove might be doing the same thing.
Why is it canceled?
You guys kind of did the same thing and then corrected it.
What do you mean?
What's your volume?
Volume is 0.0114.
Oh, excellent. But that's not what you wrote down.
We wrote it down in milliliters, but.
But I see the calculation with no units. No units, man.
Oh,
How
wow.
dare you? That is terrible.
That's what I didn't know.
Zero point zero one four four.
What is the moles of no?
No, 145.
145?
If you round it.
Okay. And then this one is
Half.
actually. Let's make that.
Wait, are we trying to find the moles of oxalic acid
Like I said.
or the?
You want the concentration.
Yeah. You found that.
Finding the moles might be an intermediate step.
I always wanted to take it down. I thought
Seven, two, three.
Really given the
723 times and to the negative 3 mole.
Oh, I didn't put it inside of the rotation.
So look, what you
They have
get is that value. That's not your
What's up, Ed? Yes, yes, yes. Never mind.
You
We
divide
have
that
to
by
use
3,
the
you get the moles of this. Multiply that by this
use the
volume,
concentration
you
from
get
that.
the number of moles.
So we have
No, that's good. That's good.
but the
Oh yeah, no, it's not. No, multiply that by divided by 2.
yeah, keep it by your eyes.
It's the same thing. 7.239 times 10 to the negative 3. And then put it as 466.
That's fine.
That is it. Very good.
Mm. Most people have gotten there in the end. A couple, you left it in milliliters. So if you take moles per liter and multiply by milliliters, what you actually get is millimoles. But if you then take that and put it over and then you divide by milliliters, you get back to moles per liter. And so it cancels itself out. But technically, if you write like 1.45 moles or whatever it is, if you multiplied by 11.4, you will get something that is actually incorrect because it's not the right number of moles. So be careful of that. If you do it as a ratio, you don't use the table and you just show the milliliters over milliliters and you multiply by a ratio, that can often work. Then you're not actually doing that. It's because the milliliters both multiply, divide out, and so the factor of 1,000 just disappears. So it is the ratio. And if you did that but then stated it somewhere, I am just using the milliliters as the ratio, I know it cancels out, then sure, fine. It's not a mistake. All titrations go like this, where you take the two things you know, calculate the moles, use the stoichiometric ratio, and then calculate the new concentration given the volume. So they're either this way or they're that way. And you never worry about products, because who cares? You just use that to balance the equation. You're always trying to find the concentration of either one of them. I put whatever we had from our data in yellow. Everything you calculated is in red. So you take the two things you know, calculate the moles, get the other moles, divide by the volume, got the new volume. Titrations are like boom, 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 boom. They were not the most complicated stoichiometry from last year, but they were like the culmination of the stoichiometry last year. So this is essentially Chem 11. We're not even calculating pH anymore. Last one, well, not last one. 10 milliliters of an unknown concentration of sodium sulfite was titrated against 0.225 molars hydrochloric acid. What do you do with data? Is another review from last year. There's your data. What is the concentration of the sodium sulfate? The only way that we could then turn this into a Chem 12, full Chem 12 question is if I asked you, once you figured out its concentration, I could say, now, what would the pH be? What is the Ka? And you use the values for that. So I would like to ask you to grab a new partner, switch who you currently have, and bring your knowledge from the last one, and do this one on the board. Find a new person. Or I can put the attendance data in and give you randomized partner.
Is it the same thing?
This is the exact same kind of type of question. I've just given you more data to work with and to figure out what to do.
Wow.
Josh, Sam,
Yep.
pick new partners.
I'm with Andrew, not Sam with Glenn.
No, I'm not. I'm with Andrew.
Okay. Andrew is very, very sexy, but he only can take on one of you. Here, and you guys switch.
No,
You have to switch partners.
okay.
Excellent.
Yeah, because over there, that's all.
In this case, I haven't given you a table, I didn't give you the equation. So this is part where you come up with both of those.
Sodium sulfite.
Is it here somewhere? Oops. Whoa.
Ounces.
And then, plus HCl.
Hydrochloric acid.
That two is
NaS2.
No, HCl is just carbon acid, so it would be, actually.
Are you canceling?
No, it's,
No, it's not.
it would be, yeah.
We can just do a regular.
do we just do like a double split through it? I'm guessing it's plus two HCl.
NaCl.
And then, I think it's balanced. Oh, you have to balance the NaCl.
Okay, so we got 10 ml of sodium sulfite.
And where is?
So it's 225. And then we have.
Oh,
And the molarity
good,
of
that's H2S,
hydrochloric
of course,
acid
right?
is 0.225.
Three
And
titration.
then that would be, no, okay, so
Yo.
Is it NaS or NaSO4?
It is sodium. What do you want?
NaS, right?
Sulfite.
Not sulfate.
Not sulfate.
It's one.
You also have your table of polyatomic ions. What's sulfite?
And then you can just treat this one to
Or which page is my table of polyatomic ions?
It's like 3 or 4. It's after the table.
so
What's sulfite? There you go. What's sulfite?
Oh, SO3 2 minus.
There you go. So sodium sulfite.
That's it.
4.
yeah, basically.
Just write it on your diagrams.
It's
So the iPhone
Yeah.
0.170.
No.
Just the average one?
Already.
Is this 0 or 6?
It's too big, so it doesn't make sense. And then what we can do is we can just convert this to the number of moles.
Oh my god. But tomorrow
That's
I'll
what I
also
know.
done in one. And if they knock out the energy,
It's still not right?
How do you get volume?
Okay. I do have a house pair meeting.
You
So as soon as each pair can show me the correct answer and good,
we're good.
you will be good to go.
what you do is you,
Get ready with an eraser marker.
it gives you 3
So when I
volumes.
say it's good, I
Just
want to
take the
erase out
average
very
of the
quickly.
Okay.
Ours
But
is
you
like
use 16.8 because 16.8 is too big, so you can, it's like a, just
what?
you can divide this by that much. And it's just like a U shape, it's kinda like.
What we did?
You're weird. Yeah.
We got
wait,
what's
can you
what's
tell me what you got? Maybe it's around there.
I'm saying you're very close, but you have made a critical error. It's more about your experimental technique than your calculation technique.
Which is
Isn't it the average of the 3 is
-3.
15.1?
Oh yeah, quickly erase it.
Is that it?
Yep.
Is
Yep.
this
These means you're good to go.
Oh yeah.
Is that it?
Oh yeah.
You're really close. You have made a critical experimental error.
We have to ignore this.
It's not about you. Your number is very slightly wrong. It's very close.
14.2.
Okay, but it's
You're
just
stupid.
yeah, one of them is
14.2. Do 14.2.
calculated
And then
again.
14.2. And then it'll be.
Oh no, it wasn't about rounding or anything. Yeah.
And then.
The sum of the numbers you used to calculate it are incorrect. You've made an assumption.
No for
That
that.
wasn't good. It's very, very close. Jordan, excellent. The ratio worked good.
See you. See you. Don't want to be
You guys good to go?
Oh wait.
Did you find it? That sounds way closer. What changes did you make on there? Because I don't see the change. Not 0.015.
One of the
That number is actually the number you have a problem with.
one of the
Hold on, where'd you
experimental
get
values is
0.01?
wrong.
Oh, okay. So the other one's 0.01 meters. Yeah, your 0.0151 is incorrect.
Which is?
Ignore the six. Ignore this one. 14 plus this. divided by
Josh, where's your group?
Divide that by 0.1.
14.2.
14.2.
Yeah.
Why 14.2?
This is just these two divided by.
because this one's F.
That's your first one where you overshot it, so you can tell by looking at it, that's
went up
incorrect.
like 600 trophies, and then I scored 6-9. Imagine making me jump again. But this one brought us up now. But they have
And the final result though,
We're allowed to go.
we're allowed to go.
It's like, I'm a little past that. Actually, my main goal is that one. I don't know.
Really?
Figure it out.
I'm fine, I could be a 9.
Okay, yo, let's go eat.
Mac and cheese.
Oh, is that what it is?
Wait, is it mac and cheese?
Oh, bro, I'm not sure.
I'm good.
You're welcome, thank you.